Okay, doing a little bit of BS here, brief summary. We ask, if this is our function, vector function, then can we figure out a function little f such that this function is the gradient? Okay? So if this is the gradient of some function little f, then, well, the gradient of little f is fxi plus fyj. Excuse the tall I, had the x a little high there. So if this function is a gradient of little f, then 4xy cubed is fx, 6x squared y squared plus 3 is the fy. So we take those two equalities. If 4xy cubed equals fx, then f must be antiderivative of 4xy cubed with respect to x. And that's going to be 2x squared y cubed, and you can verify that easily, plus an integration constant. In this case, we're integrating with respect to x. And remember, if we're just dealing with integrals and derivatives with respect to x, any function of y is constant with respect to x, right? So that our constant, our integration constant, is going to be g of y. Okay. And then we take our fy equal this, and we find antiderivative with respect to y, and we get this, plus our integration constant. Okay? And our integration constant with respect to y is any function of x. So that our f function is this, but it's also this, meaning that this has to equal this. So we set this equal to this, and we very quickly conclude that g of y is 3y, and h of x, well, g of y could include a constant, h of x could include a constant. So, but we don't have anything else. We don't need anything else for our h of x, and actually we can't have anything else in our h of x or it would mess up our x derivative. So that our g of y, we're going to say, is 3y plus a constant. Our h of x is then going to just equal that constant. And f of xy is this, and then this function is the gradient of this function, so this function is the potential function for this. And notice that we can add an arbitrary constant to any potential function.